Okay, so on this one, it's a difference of squares. X plus 4, x minus 4. Raise your hand if you had that one right. Okay, good. Let's move on into the tougher stuff. This is also difference of squares. It's just harder. Give it a try. Actually, write the answer on the paper. Or on the iPad. In the virtual paper. So what do you think? What should I break it into? 12s? What are you talking about? X to the 4th and x to the 4th, and then a plus of 4 and a minus of 4. Did anybody go farther, though? Because this is a common wrong answer because you haven't factored it all the way, and you know, what is it? Yes? Yes, except you're wrong. No, hold on. X squared minus... Oh. You're just not taking the square root of the 4. Square root of 4 is 2. Okay, so it's x squared plus 2, x squared minus 2. And then this one just drops straight down. X to the 4th plus 4. Because when it's not a difference of squares, when it's adding, you can't do that. But if it's a subtract, you can do that. Okay, if I wanted to prove that this was right, some of you are like, how come you can do that? Because this times this makes that. Outside and inside would cancel. And then that times that makes that. Yes? 4 times 4 does not equal 8. You are correct. 4 times 4 equals 16. This times this makes that. Oh, did you think that they were going, when you were doing x squared times x squared, were you thinking it was going 2 times 2 makes 4? But it was actually adding. Let me give you an example. X cubed times x to the 2nd, that is not x to the 6th. That's x to the 5th. You're actually adding. Okay. All right. So bottom line is, this has been factored all the way. But, you know that crazy teacher who makes the keys sometimes goes a little farther, and I kind of like this. I want to make sure you understand it. What if you took this part right here and factored it? How can you factor that? You can factor that if you use not imaginaries in this case. Well, actually, wait, this would be imaginaries. Sorry. Yes, you'd need imaginaries. So watch. X squared and x squared makes the x to the 4th part, right? You always need a plus and a minus to make this kind of thing work because it has no middle term. You need the outside and the inside to cancel each other. And then, well, why isn't it just 2? Well, because then it wouldn't actually work. Because this is a plus. So what's different is you have to throw in an I. Now let me make sure you understand why that works. Watch. First, x to 4th. Outside and inside cancel. So it's all about these last two. What is it when you take 2i times negative 2i? Some of you are not listening. Listen. 2i times negative 2i. What happens? Well, a 2 gets times by the 2 and you get negative 4. You get that part? Negative 4. And then the I gets times by the I and makes I squared. And I squared is really negative 1. So negative 4 times negative 1 ends up making 4. Which is what we wanted. See? 4, not negative 4. So, moral of the story is you can factor that farther. If any of you understood that, try this. Factors. The factors if you use imaginaries. Yeah. Once you see it, you'll be like, oh, yeah, duh. Okay. Do you have to do this? No. But it helps you. I'll show you why it helps you. One second. If you do know how to do this, I'm going to say do. If you do this, it'll help. All right. X and X and plus and minus. And it can't just be 2 and 2. Otherwise, that would make it like a normal one where this is minus. So, throw in an I. Here we go. Raise your hand if you had it right. Okay. Now, what's cool about it is You know, when they ask you the answers for this, you'd be able to say, oh, what's x have to be here to make this part 0? X has to equal 2i. And what would x have to be there to make it 0? X would have to be negative 2i. See how you get the answers pretty quick then? So you don't have to do it that way, but if you do, then you get your roots really easy. All right. Otherwise, what would I have done? I just say, take this and set it equal to 0, solve. But you know where kids often screw up on this one is when they take the square root and they go x equals square root, and even if they do this right and say, oh, it's 2i, they forget that there's two answers, plus and minus 2i, see? Whereas on this one, it's pretty obvious you got to have two answers because there's one for this and one for that. This one, it's really easy to just think you're done right there. It's really plus and minus 2i. Okay, yes. Okay, the question was this. If you leave an answer like this, for instance, yeah, that would be wrong because it's not, I know what you're saying. The other one before, it was different numbers, but it's the same concept here. Can you leave it this way? No, you have to go farther. This one has to get factored further. X plus 1, x minus 1. And this one does not have to get factored, but it could in the way I just showed you. Who can do this? What do you think? X plus 1i and minus 1. Yep. And then my four answers, two of them are real. X equals negative 1 and x equals 1. And this one's answer, negative I, and this one's answer, positive I. You can, but this would be a multiple choice test, and I don't think they're going to require you to go this far. You're just going to be required to go this far. So the final answer you'd be required to do. No, it is not all multiple choice, but a lot of it is. Yes? Yes, 1i is the same as I. Yes. All right, moving on. This one. If you're getting this concept of factoring the ones with a plus, it should be quick, quick, zip, zip, easy. The cool part is, if you know you did it right, no, if you don't know you did it right, you can find out really easy. Let's say I think the answer is 3, and I actually multiply this out. First, give me x squared. Yay. Outside and inside cancel. Last, give me a negative 9. Wait a minute. Didn't give me the right thing. See what I mean? It's a factoring test. You can check yourself on every single problem. You can multiply it all back out and see if it worked. You can know if you got it or not. I know I did not get it. So what did I do wrong? It should be I. Why? Because this is not a minus, it's a plus. So I need to use imaginary numbers to make it work. And why does that work? Because the first would be fine. The inside and outside are fine because they cancel. But it's this times this giving me 9. That's kind of weird. Negative 3 times 3 makes negative 9. And the I times I makes I squared. Negative 9 and negative 1 makes positive. All right. Didn't need to know that, but I didn't want other kids from other classes who had learned that to be able to kick virtual sand in your face and say you're a half win because I can do this. Oh! That was weird. What just happened? I just got my hand near the mic and like crazy. Hello, hello, hello. All right. Anyway, do the divide and conquer on this one. That's a crucial skill for the big test. 4-part factoring. Sometimes people call it factor by grouping. Oh, you're fat. Can you just put them in one of your outfits? Just one of them. That's a little confusing. what happens when you're on ESPN. All right. Hopefully you said x squared comes up. This first. X squared comes up. What do you got left? X plus 5. How about out of the red part here? What comes out? -6. What's left? And that happens to match with that, which is perfect. X plus 5 comes out in front. X squared minus, don't interrupt, x squared minus 6. Raise your hand if you had that one right. Good. Now question. Don't have to. Put it at the end. But when I would ask you this. When you factor out like an x out of both of those, you put it at the end? I always put it at the front. Because that's what's going on, is I'm taking something out of both of them. When I take something out of both of them, I usually put it in the front. Okay? So that's why I put this in the front. But if I put it at the end, it'd be fine. It'd be the same thing. I guess. You want to be extra smart. Go ahead. So tell me what you would get. You would be wrong. Try again. Exactly, that's what you put. Square root of 6 and x minus square root of 6. Yes, you could do that. You don't have to, but you could. Because it actually works. Yes. Is it imaginary? No. Because this is a minus. I can make this part equal 0 without imaginary numbers, see? Yeah. So, if that was a plus right there, if this was a plus, then you would have needed imaginaries. Yeah. Okay. Moving on. Not that. How about that? This kind, you'll need a calculator because you can't divide and conquer because it's got 5 terms. You're going to calcularize it. Whoever's up here gets first priority. Hey, L, Mr. R, Logan, bring it back. You can't grab multiple calculators because other people are standing up here. They get to get them. Okay. Right there. There's more. Push the little thing. Okay. Yes, I said a name, but I had no choice. All right. So this problem needs to be graphed first. You'll find out where it touches. After that, you'll have a chance to factor it and then factor it again. I'll warn you, this one factors more than once. Because if you stop halfway, you don't get any credit. I don't remember where I paused, but anyway, I'm recording again. This one here has a missing term in it. Make sure that you do your synthetic correctly so it counts for the missing term. Okay, on this one, what was the thing that worked? Well, there's actually a couple different things you could have picked. What was one of the places it touched? 1? -1 or 1? 1. All right, so put in a 1. And then I'm going to go 1, 2, -1, -2, and what did I just do wrong? Missing term. Okay, so between the 2 and the -1, I need a missing term. 0. And now I'm ready. Okay, and I draw the line. And this one is really weird. I did this one on purpose, knowing that it was going to come out weird. And you may not even have noticed that it came out weird. 1 times 3 is 3. Add them. 3. Multiply them. 3. Add them. 2. Multiply them. 2. X is 0. It worked. So my answer is this. X minus 1. And then this part. X squared. X cubed. Add. And then the other number should come out now, right? Okay. What's the other thing that worked besides 1? -2. So I put a -2 here. I do my synthetic deal. 1, 3, 3, 2. Draw the line. Drop it. Multiply it. Yes. Multiply or add it. 1. Multiply it. Add it. Okay, who's making the noise? Stop it! -2 adds up to 0. Okay, good. Final answer. This comes down, x minus 1. This comes down, x plus 2. And these guys right here, that's x squared, make x squared plus x plus 1. But here's the weird thing. That's a right answer, but some other kid in here has got a totally different answer that's also right. Who's got a totally different answer? I know somebody must have done it a different way. Maybe you were like, oh, I must have did it wrong. Okay, then I want you all to go back because you all happen to use the same root at the same time. If you had started with -2, okay, if you started with -2, is this the problem? There's another problem after this. No, this is the problem. Let's see what happens when we start with -2. Start with -2. And then I get 1, 2, 0 to hold the place, -1, -2. Line. And you get x plus 2. And then, what's that? X cubed minus 1. That is a right answer also, and it's totally different. Yes, the x cubed minus 1 can factor, but a lot of people wouldn't know that. Okay, how do you do it? Well, you'd go back and say, well, I know there were two things that would work. 1 would work and -2 would work. I already used the -2. Now I have to somehow get a 1 to work in this, and it will. If you go 1 and you make the little synthetic deal, and you go, what are my numbers? It's 1. I've got two missing terms, the x squareds and the plain x's, and then a -1. It will work, but this one comes out really weird because of that. Add them, multiply them, add them, multiply them, add them, 0, hold the place. And again, it'll come out to the same thing we had in green there in the first place. But this is because we haven't taught you how to factor differences of cubes. You will learn that in pre-calc. But can you factor differences of cubes? Sure. Just graph it. You'll find out that it touches at 1. You do synthetic on it. So this little process of graphing it and finding the roots that way is a really good idea. All right. That covers pretty much everything that you need to know. We didn't talk much about finding the actual roots. Like when you're done with this, you'd have to say, what are the answers? This is the factoring. What is the answers? Well, x equals 1. This one's x equals -2. That one, ugh. How do I get the answers for that? What if you can't get the zeros any other way? What always works? Quadratic formula would work. Quadratic formula. No, synthetic won't always work if you don't know what the factors are. If you don't know one of the factors is to test in the little synthetic box. So the moral of the story is this one would be a really tough one because of that. All right, a more typical problem ends like this. What would the answers for this one be? What's the answer for that part? Okay. And this part here, x squared minus 3 equals 0. X squared equals 3. Square root on both sides. X equals square root of 3. Wrong. Plus or minus. 2 answers for this, which makes sense. It had 2. 1 answers for this. Total of 3 answers. This thing, if I multiplied it all the way out, would be degree 3, so it makes sense. Okay. Were there any imaginaries? No, there were not any imaginaries because there's no i's here. Square root of 3 is not imaginary. If there had been a negative in there, then you'd have to make it imaginaries. An I. Yes. If you had this and you're trying to make it equal 0, okay. So if I say equals 0 and then I say x cubed equals 3, then how do you get rid of a third power? Yes, cube root. But if you don't know how to do that, which most people don't on the calculator, you put both sides to the power of 1/3. Because 3 to the 1/3 power is 1, and that means x to the 1. And then 3 to the 1/3 power here, whatever 3 to the 1/3 power is, use the calculator to type in 3 to the power of 1/3. It's going to be some 1.237 or something, third decimal. Fine. Okay. Fine. Okay. There we go. That's beyond what we even need to do.